When you think about it, our accumulated knowledge of the mysteries of space is not much, so it should not surprise that there are plenty of surprises out there. The latest of this is the discovery of an alien world with a strange tilted orbit that has puzzled astronomers. For today's journey, we won't be traveling too far to reach strange discoveries. Now is the time to like, subscribe, hit that notification bell, strap up, and move out, because we're about to blast off. Welcome back to Space Infinity. We seem to be discovering interesting things about our universe all the time. Still, we know so little that it is entirely possible for something to come along that we've never seen before. After all, while we can observe faraway bodies and elements using our vast array of telescopes and equipment, we only really know how the physical operation of solar systems works as it applies to our own solar system. There are potentially whole other arrangements out there that could be far beyond anything anyone has imagined. The study of exoplanets, then, has been something that has provided our best and brightest with an ever-expanding knowledge base with which to predict other astronomical phenomena. Because every time we find a planet that has a different makeup or a wildly different behavior from what we know, it's an opportunity to apply that knowledge to further searches. So then, the recent portrayal for the first time ever of the orbit of an exoplanet in a binary star system should be cause for celebration, and it is. However, there is a strange tilted orbit in play here. The planet in question orbits its star at a different angle to the planet of the orbit of the two stars, and the misalignment could actually offer clues as to how planets are able to form in binary systems. More than 4/5 of the single points of light that we observe in the sky are actually two or more stars that are orbiting together. The most common of all multi-star systems are actually binary stars, meaning systems of only two stars together. These pairs have presented themselves to scientists in all manner of different configurations that have helped scientists to classify stars and could have major impacts on the development of life. Some people even suspect that our own sun could be part of a binary system. Binary stars are two stars orbiting a common center of mass, with the brighter of the two being classified as a primary, or A, capitalized, star, while the dimmer is the secondary, or capital B, star. In cases where the stars are actually of the same or similar brightness, the designation of A and B is given to the person who discovered them. Binary pairs can be classified based on their various orbits. Wide binaries, as you might expect, are stars that have orbits far apart from one another, evolving separately and with little influence from their companion. They might have previously had a third star, causing them to eject away from each other. Close binaries, on the other hand, evolve near to each other, transferring mass from one to the other, with the primary often consuming the material from the lesser star or exerting its gravitational pull over the secondary body. There are also visual binaries, close enough to be viewed together through a telescope, or even binoculars. Spectroscopic binaries that appear close when viewed through a telescope, eclipsing binaries that can eclipse each other, and astronomic binaries that seem to dance around in empty space, where the secondary star is that much harder to see for various reasons. The first binary stars observed were in 1617, when Galileo was requested to turn his telescope towards the second star from the end of the handle of the Big Dipper, discovering that one star seemed to be two, but actually turned out to be six. The term was later coined in 1802 by Sir William Herschel, who catalogued about 700 pairs of stars. One of the most important benefits of registering binary star systems for scientists is that it allows for those scientists to determine the mass of a star. As a pair of stars pull on each other, astronomers become able to calculate the size and, from there, determine characteristics like radius, as well as temperature. These variables have helped to characterize single main sequence stars throughout the universe. So it's clear that scientists owe a lot to binary systems. But that too is why this latest discovery is so important. The new planet. This discovery of a tilted orbit in an exoplanet is highly exciting, challenging what we know already. The exoplanet GJ896AB, with a lowercase b, was found in the binary system GJ896AB, capitalized for the stars, which is located about 20.3 light-years away from our planet Earth. Astronomers were able to follow the motion of the star system through space with the help of archived optical observations dating from 1941 up to 2017. Also using data from 2006 to 2011, gathered using the Very Long Baseline Array, or VLBA, a network of 10 radio telescopes that are strung across America. The team of astronomers, led by Salvador Curiel of the National Autonomous University of Mexico, or UNAM, found that as the A star moves through space, it seems to wobble somewhat, This bizarre wobble is caused by a planet in orbit around it, with 2.3 times the mass of Jupiter, which completes its orbit every 284.4 Earth days. In between the planet and its star is a common center of mass called the barycenter, and the star's wobble is caused by its motion around this common center of mass. Astrometry, the application of detecting the motion of stars through space and observing any deviations in the typical motion, is called astrometry. Astrometry is the only way in which the orbits of a given planetary system with more than one star can be interpreted in 3 dimensions, since the astronomers are visibly identifying the wobble and the orientation of orbits. Interestingly, the plane on which this particular planet orbits is actually misaligned by 148 degrees, relative to the plane of the orbit of the 2 stars around each other. Gisela Ortiz-León, an astronomer at UNAM and the Max Planck Institute for Radio Astronomy in Germany, as well as a member of this project's team, said, "This means that the planet moves around the main star in the opposite direction to that of the secondary star and the main star. Very odd indeed. Actually, less than 4% of known exoplanets are in binary star systems. This small proportion is actually because it's quite a bit harder to detect planets in binary systems, but also because the models used by scientists suggest that the existence of a companion star can truncate and destabilize a planet-forming disk." UNAM's Joel Sanchez Bermudez acknowledges this gap in knowledge and says, maybe those models need to be adjusted. That's how important a discovery this has turned out to be. One of the bigger problems in forming a system for these phenomenon is that gas giants are thought to take about 5 to 10 million years to accrete all of their gas from the planet-forming disk around them. But the current model suggests such a disk in a binary system survives for less than 1 million years before the tides of gravity from the companion star break the disk entirely. Also, in the case of GJ896AB, the 2 stars are red dwarfs, which makes the existence of a gas giant in their system even more of a surprise. Scientists think red dwarfs lack the necessary amount of material to form giant planets. But the presence of a gas giant in this system definitely suggests that it is possible for planets to form differently when there are 2 stars present. Sanchez Bermudez added, additional detailed studies of this and similar systems can help us gain important insights into how planets are formed in binary systems. There are currently 2 models competing to explain how binary systems and their planets form. The first is disk fragmentation, wherein there is originally just 1 star and planet-forming disk that becomes unstable and eventually breaks away into 2 separate disks, ultimately forming 2 stars as well as their planets around them. The other model is called turbulent fragmentation, and this explains the occurrence by hypothesizing that turbulence in the original gas cloud leads to 2 or more dense concentrations of material forming, which both independently collapse, forming the stars and their accompanying planets. Both of these models, however, have yet to account for the strange misalignment of the planet GJ896AB by 148 degrees. This means that whichever model is able to replicate the odd system could become the model best indicating how the formation of binary systems actually does occur. In any case, the discovery of planet GJ896AB is something that is going to make huge waves in the scientific community, as we hurry to try and understand this latest surprise in our ongoing endeavor to comprehend the universe. What do you think about this discovery? Leave your report in the comments section below. Then make your way to the like and subscribe button if you haven't already. And for the next immediate space infinity journey, click on these videos to be guided to the massive database of space knowledge.